Hello and welcome everybody to our channel's tutorials. If you have not subscribed our channel, please subscribe our channel so that you don't miss our videos. Today our topic is scientific observation, the basic technique of scientific method. Science is based upon verifiable evidence. By evidence we mean factual observations other observers can see, weigh, count and check for accuracy. Scientific observation is not the same as just looking at things. We have all been looking at things all our lives, but this does not make us scientific observers anymore. Then a lifetime of sweating flies makes us entomologists. How does scientific observation differ from just looking at things? Scientific observation is accurate. The scientific observer tries to make sure things are exactly as described and avoids jumping to conclusions. Novelists make fantasize and politicians exaggerate, but the scientist must try to be accurate. Scientific observation is precise. While accuracy refers to the truth or correctness of the statement, precision refers to the degree or measurement. No respectable social scientist would say, I interviewed a lot of people and most of them feel that things are terrible, and claims this was a scientific investigation. The question will arise here such as, how many people, what measuring instruments, how terrible? Since scientific writing is precise, scientists avoid colorful literary extravagances. Tennyson's lines, every moment dies a man, every moment one is born, is literature, not science. If written with scientific precision, it might read, every 0.596 seconds, on the average in 1980, died a person. Every 0.2448 seconds, an infant was born. They made the writing, maybe, intentionally vague, stimulating the reader to wonder what is meant, but the dramatic sweep of the novelist and the provocative imagery of the poet have no place in scientific writing. Scientific observation is precise. How much precision is needed? A billionth of an inch is too large error for a nuclear physicist and a social scientist. How did housing measure to the nearest square foot is satisfactory? Scientists seek as much precision as the situation requires. If conditions of observation do not permit such precision, the scientist must qualify judgment until more precise observation can be collected. Scientific observation is systematic. Conclusions based on casual recollections are unreliable. Judgments which begin with, I talked to a lot of people, should be classed as conversations, not as research. Unless observations have been collected in an organized, systematic program, they are likely to be spotty and incomplete. Scientific observation is recorded. Human memory is notoriously fallible. Suppose the professor says, women usually don't do as well in this course as men. This professor has computed average scores for men and women students. He is saying, I have recalled the grades of hundreds of students, mentally computed averages and found the male average score to be higher. The attack episode of such a statement shows how untrustworthy are all conclusions based upon recalling unrecorded data. Scientific observation is objective. This means that insofar as a humanly possible observation is unaffected by the observer's own beliefs, preferences, wishes, or values. In other words, objectivity means the ability to see and accept facts as they are, not as one might wish them to be. It is fairly easy to be objective when observing something about which we have low preferences or values. If It is fairly easy to study objectively the mating practices of the fruit fly, but less easy to view the mating practices of the human beings with objective detachment. On any matter where emotions, wishes, habits, and values are involved, we are likely to see whatever agrees with our emotional needs and values. To be objective is perhaps the most taxing of all scientific obligations. It is not enough to be willing to see facts as they are. We must know what our biases are if we are to guard against them. A bias is simply a tendency, usually unconscious, to see facts in a certain way because of one's habits, wishes, interests, and values. Thus, a peace demonstration is seen by some as a courageous effort to save the world from collective suicide, while others see it as a misguided effort to replace hard-headed realism with idealistic mush. Seldom are the facts so undebatable that bias does not distort them. Selective perception is a tendency to see or hear only those facts which support our beliefs and overlook others. Many experiments have shown that most people in a social situation will see and hear only what they expect to see and hear. If what we expect to see isn't there, we see it anyway. This is dramatically shown in a famous experiment in which observers were shown a picture of a roughly dressed white man holding an open razor and is doing violently with a well-dressed up black man who was shown in an apologetic posture. Then the observers were asked to describe the scene. Some of them saw the razor in the black man's hand where they expected to be. Audience perceived it correctly, but in passing on a description of the scene of this phenomenon, had the razor in the black man's hand where it belonged. Even though they were involved in the situation, had ample time to study it, and were making conscious efforts to be accurate in what they saw and reported or heard, the observers' unconscious biases still led many of them to see or hear a fact that wasn't there. Some common threats to objectivity, then, are vested interests, habits, and bias. Objectivity does not come easily to an observer, but it can be learned. One can become more objective as one becomes aware of personal biases and makes allowance for them. Through rigorous training in scientific methodology, through studying many experiments and noting many examples of objective and unobjective uses of data, an observer may eventually develop some ability to cut through many layers of self-deception and to perceive facts with a greater degree of scientific objectivity. The scientist has another powerful ally: the criticism of colleagues. The scientist publishes research so that it may be checked by other scientists who may not share the same biases and who come to the problem with a different point of view. This process of publication and criticism means that shoddy work is soon exposed, and scientists who let bias dictate the uses of data are open to severe criticism. Scientific observations are made by trained observers. 1 billion people first believed that the sun and moon sweep across the sky. More sophisticated observers know that it is not exactly what happens. Untrained observers do not know what to look for or how to interpret it. They do not know the pitfalls which lead to inaccurate observation, nor are fully aware of the tricks their own limitations and biases may play on them. Startling reports of weird phenomena generally come from an educated and sophisticated person and are discounted by the experts. When some remarkable observations are reported, the scientist will want to know, number one, what is the observer's general level of education and sophistication? Is this person a member of superstition-ridden folk group or of a well-informed and somewhat skeptical population? Number two, what is his special knowledge or training in this particular field? Does this observer have the knowledge to tell whether this event has a perfectly natural explanation? Thus, the biologist among the ship's passengers is less likely to see a sea monster than are the members of the crew, and the meteorologist sees fewer UFOs than people with no special knowledge of atmospheric phenomena. In recent years, public interest in psychic and occult phenomena has exploded. A book claiming that plants have consciousness and are responsive to human feelings has been a bestseller. Although scientists are generally unimpressed and there are no authenticated reports that anyone has yet hated the crabgrass out of the lawn. At one time, stage magician Uri Geller has attracted great attention as a psychic and has even impressed a team of physicists at Stanford Research Institute. But physicists and other scientists, whatever their credentials as scientists, are not trained observers of sleight of hand deception. Stage magicians consider the scientists as easy to fool as anyone else and generally dismiss Geller and other psychics showmen with no psychic powers. Obviously, a trained observer must be trained in the particular kind of observation he or she is conducting. Many events happen without any scientific observer on the sideline. If each sea monster broke water before a panel of epidemiologists and each revolution was staged before a team of visiting sociologists, our knowledge would be far more complete. But for many phenomena, the only reports we have are the casual impressions of untrained observers who happen to be there. These reports may be interesting and useful, but must be interpreted most cautiously by scientists. Scientific observations are made under controlled conditions. Laboratories are popular with scientists because they are handy places to control variables such as heat, light, air pressure, time intervals, or whatever is important. A variable is anything which varies from case to case. For example, people vary in height, weight, sex, age, race, income, health, religion, education, occupation, behavior, characteristics, and many other things. We have a scientific experiment when we control all important variables except one, then see what happens when that one is varied. Unless all variables except one have been controlled, we cannot be sure which variable has produced the results. If we wish to study, say, the effects of phosphates on plant growth, all other factors like seed, soil, water, sunlight, temperature, humidity must be the same for all the sample plots. Then the varying amount of phosphates on different test plots can be held responsible for different growth rates. This is the basic technique in all scientific experimentation. Allow one variable to vary while holding all other variables constant. There are complicated statistical procedures for multivariate analysis which can enable the researcher to work with two or more variables at a time. But this is only a refinement of the basic procedure of holding all other variables constant in order to measure the impact of the one or more under study. Failure to control all variables is a most common error in scientific method and accounts for most false conclusions. For example, a number of studies several decades ago concluded that the employment of mothers increased child delinquency, but these studies failed to control the variables of family and social class composition. A sample of working mothers who were mostly poor, uneducated, often widowed or separated, and living in wretched neighborhoods was compared with a sample of more prosperous, better educated, and living with their husbands in good neighborhoods. No wonder they found strong association between maternal employment and child delinquency, which more recent research does not fully confirm. Failure to control some variables such as social class, education, age, and occupation are common ones has invalidated many research studies. Since laboratories are such convenient places to control the conditions of observation, scientists use them whenever possible. But much that is important cannot be dragged into laboratories. Volcanoes and earthquakes cannot be staged in a test tube, nor can we study the courtship process very realistically by herding couples into a laboratory. Both physical and social scientists frequently must observe phenomena in their natural setting. Techniques may range from lowering a bathysphere to the ocean floor to giving a questionnaire to a group of army recruits. If we remember that the basic scientific procedure is the conducting of accurate observations, while laboratories, instruments, and computers are merely tools of observation, this difference in technique will not confuse us. The scientific critic will trust a report observation only insofar as the conditions of the observation have been controlled. On this basis, scientists are skeptical of the claims of spiritualism and mind reading. Spiritualists can conduct a very convincing seance in their own stage setting, but are loath to attempt a seance where the room, furnishings, and lightings are controlled by the scientist. The professional mind reader is very convincing in a theater setting but unwilling to attempt a reading under scientifically controlled conditions. Until spiritualists and mind readers make demonstrations under conditions which preclude the possibility of deception, scientists should dismiss them as either entertainers or frauds. Is it not strange that most of those who claim to foresee the future are performing in shabby carnivals and nightclubs instead of raking in millions in Wall Street? Why has no professed mind reader ever won a world chess or bridge championship? Although there are occasional newspaper reports of some psychic having solved a crime, is it not significant that police departments and intelligence agencies do not routinely employ psychic detectives? Although many exposes of the tricks of psychics, mentalists, fortune tellers, astrologers, and spiritualists have been published, their popular following today is greater than at any time in recent history. In these several respects, then, scientific observation differs from looking at things. We spend our lives looking at things, and this activity brings us much information, many impressions, and numerous conclusions. But these conclusions are clouded by accident of coincidence, by selective memory, and by personal bias. Therefore, before accepting any generalization as true, the critical observer wants to know what it is based upon. Is a conclusion based upon a systematically collected body of scientific evidence, or is it an offhand reaction to haphazard observation? So this was all for today. If you like our video, then comment, share, and do not forget to subscribe. Thank you very much.